So in this video, we're going to go through the Fundamental Theorem of Calculus, Part 1. This particular theorem is split up into two main components. There'll be a second video on Part 2. If you just want to go through the actual examples, you can skip to that part of the video. For now, I'm just going to explain what the first part of the Fundamental Theorem of Calculus is. So the theorem states just if f is continuous on some interval a to b, then a separate function g of x can be defined as the integral of from a to x of f of t dt. The derivative of this, of g of x, is simply just that variable put into your original function. All right, so simple as that. We're just going to go through a couple of examples that demonstrate this. First example here is we're going to find the derivative of these functions using the Fundamental Theorem of Calculus. The integral from -7 to x e to the 2t cosine squared of 1 minus 5t dt. So this is just a simple substitution, right? Especially since it's a simple substitution whenever our upper bound is just x, nothing else to it. So the derivative of this, g prime x, is just e to the 2x cosine squared of 1 minus 5x. Right, simple substitution. Now the next couple of examples we're going to go through are whenever that value isn't just a simple x. Now here, in example 2, we have g of x is equal to root of x as the lower bound and 2 as the upper bound of a squared over a squared plus 1 dA. So first, the Fundamental Theorem of Calculus is only going to work if your variable's in the upper bound. So we just need to flip this integral, and the rule for doing that is if we're going to flip an integral, we need to negate the entire thing. Now we can do our substitution. Now, there's a second part to doing these problems when you don't have just some x value as your upper bound. Okay, so you have to do your substitution, which in this case is going to be, root x to the second is just x. Root x to the second is just x, and then plus 1. And then this whole thing gets multiplied by the derivative of whatever that upper bound is. In this case, the derivative of square root x, or x to the 1/2, is just x over 2 where the x is to the -1/2. And this would be your final answer. Last example we're going to go through is right here. Now, similar to the last problem, we don't have our variable in the upper bound. So we're going to flip our integral here. In case it's difficult to read, what we're starting with is the integral from x squared to 4 cube root of s to the 5th plus 6 ds. Okay, so we flip our integral, so it's 4 to x squared, and we negate the whole thing. And now we can do our substitution. So we have a negative and then cube root of x squared to the 5th, which is x to the 10th, plus 6. And now we multiply this by the derivative of our upper bound, which is x squared, so multiplied by 2x. And then just to simplify this, we can multiply these two together and end up with negative 2x cube root x to the 10th plus 6. All right, and that's it for the first part of the fundamental theorem of calculus. It's honestly not going to come up that much. The second part is really the crucial component of this. So head to that video to, quite frankly, learn something that you're going to use through all of, whether you're studying math, engineering, or physics. Like, this is, the fundamental theorem of calculus. The second part of it is one of the most crucial things you'll learn from whatever course you may be in now, either Calculus 1 or AP Calculus. Right?